Awesome, last talk of the day. Thanks for that, organisers. That's great. I'm just going to get up to spin a bit of a yarn as to what I did last year. I went to the corporate. I'm no longer there, so foreshadowing. New year, who dis? I'm Sam. I've been making apps since I was 17 years old. I'm older than 17 now. I tend to wander off though into other frameworks. My wandering's taken me to C#.NET, Ruby on Rails, things with AWS, and most recently I'm on React and Node, TypeScript, and Azure. But iOS is my bae. Today I'm going to talk about software engineering, what it really means, and what that meant in terms of a corporate environment last year. We went through introducing a UI framework, and there were some mindset changes to go through, and there were plenty of lessons learned. So what is software engineering? This is my favorite definition I've learned so far. Software engineering is multi-version, multi-person programming. When you're coding on your own, you don't have to read other people's code. People don't have to read your code. You've written most of the code yourself. You have full control over the code base. But that multi-version part, that multi-person part, that's where the fun really starts. Last year I worked at a place, let's call it Acme. The actual company is not really important. I think this is a corporate environment talk. I don't think it's a company name talk. We had two applications, App A and App B. You can think of these like the Uber driver and rider apps. They shared a look and feel. Sometimes the customers would use both, but generally they have non-overlapping users. At Acme's teams, it looked like this. We had 2 iOS developers and 2 Android developers in a team, but don't worry, we actually got on fine. We had a business analyst who was essentially a scrum master. They did interfacing with other teams. They'd gather analytics to help us make decisions, business requirements, that sort of thing. And we had a product owner who owned the product, decided the future of the feature and what we were doing. And we also had 2 testers per team. Together as a team, we worked on features for these apps. We would ship the feature together on iOS and Android, aiming for the same time if it made sense. And as a team, we would solve problems together. So we would discuss what solutions might work in one code base, might work in the other. We'd dive deep into the problem space and figure out what the market looks like for this feature, user experience research, that sort of stuff. Ultimately, it gave us focus as a team to worry about features. But on the horizontal here, we had what's called chapters or guilds. And in our chapters and guilds made up of just iOS developers or just Android developers or just testers, we do things like code review, code architecture, standards, linting, that sort of stuff. We would sort of own the iOS code base as a whole. In the iOS chapter, we had about 12 people. So the stories today are from the iOS chapter. So here's our code base. It was a mono repo with 2 targets, one for App A and one for App B, and a few frameworks that were included in both. So when you built, you automatically got the latest stuff in the middle. We called this common, because it was common to both apps. Inside these apps, well, you can think of these apps as a collection of features. So features exist in either App A or App B or in common. And these features were made up of views, business logic, models, API calls, glue, utilities, that sort of stuff. So as I started to work on this code as I joined the company, I started to come across code that looked like this. If App A, do something, otherwise do something else. And explicit behavior for one app in a place that was shared, it smelled bad. It was a code smell. Apple doesn't write code into UIKit that says, if it's Sam's app, do this special thing. So why were we doing it in a place that was meant to be shared? And this is where it just gets embarrassing, the testing side of this. When you changed common, it was your responsibility of you and your team, your testers, to test everything that could have changed. So that means both apps, App A and App B. But we mainly worked in App A. So our testers had to go over to App B, check it out, unfamiliar with how it's meant to work, and then test it. So it's not a good test. If you don't know what you're asserting at the end, what are you doing? So we didn't set up our testers for success at all. We realized we were performing a process without impact on quality. This was due to an aging code base that's been around since 2013, a lack of technical leadership, a fundamental misunderstanding that code can actually rot, a lack of empowerment to fix it, and a lack of buy-in from other developers, testers, and the organization to fix it. So this brings me to my first lesson. I'll be calling out lesson slides as we go along. don't share features across app unless they're never, ever going to change between apps. And I can almost guarantee that almost never happens. So we found that features just aren't sensible units to share. So it's time for a change. Time for the first mindset shift. And I'm also going to have mindset shift slides as we go forward. We are working towards a target state architecture. What's a target state architecture, you ask? Great question. Target state architecture is what you want your code base to look like without tech debt. It's where we want to get to as a chapter. Each pull request to the code base was either a step forward or a step back from the TSA. Now we all know that in software engineering wisdom, rewrites are generally infeasible, but iteration to a TSA is a very feasible way to get to something much better. I see TSA as something like akin to a working agreement in Agile or even company values. It's something that you should get together as a team, decide, debate, discuss, and then put it up on the wall. And remember that each change you make is once again towards TSA or away from TSA. So lesson number 2 is take the time to make sure your team agrees on the target state architecture. Get it out of the head of the seniors. Most seniors you'll have in your teams will sort of know where they want us to take it, but getting it out of their heads and getting it up on the wall so everyone understands it, everyone agrees on it, is really good. It's easy for onboarding. Hey, welcome to the company. Yeah, I know, but we're trying to go here. And also it's easy for debate settling. Hey, your pull request, it's not what we agreed on what we're doing. Can you do it again, please? So this was our TSA, sharing what is truly common. Nothing specific to one app should be in the other, and no changes to one app should affect the other. So this is what we had. Code in common existed in both apps, and it was really hard to change it without impacting the other. You'd end up writing if app A. So this was the goal. The TSA would have app A and app B, and these each had their own dependencies on something like a UI library called a style guide, a utility library, an API library, and many more. And each app would be custom business logic, custom glue that brings these dependencies together and produces the experience. Modules mean one thing. We are now making code for our teammates to use. We hadn't really done that at Acme before, so it was a big mindset shift for us. So, modules. We wanted to start making modules. Where to start? We wanted to almost prove it to ourselves that we could. And we didn't really have permission to do this, but it is on the chapters at Acme to sort of architect their own code base. So that's sort of how we told ourselves it was okay. If you said to management, hey, we're going to go on a multi-month rewrite of a piece of the app, so we just started. We started with the UI component library. It made the most sense to us. We had a few components emerging organically, so it was worth formalizing that into a dependency. So we did the initial build, and it contained the usual suspects you'd have in a UI library: fonts, colors, UIView subclasses. We had a lorem ipsum generator, one of those duvet view controllers that every app's having to make themselves now. That's the sort of stuff. It was a Cocoa Touch framework as well. And we formed a little committee to work on this initial build. We had 2 devs, one more junior, one more senior, from app A and app B, and we also pulled in our usual iOS designer the whole way through. And that was a good thing in hindsight. The reality is the build time for this initial build happened in just a few hours. We made the framework, file generate new. We moved over the components, renamed them, re-imported them, got it building, and then fixed interface build and its runtime issues, and we're up and running. It was like we took lunch at like 1 and we're done. It was great. So we were done. Right. The proof of concept, the code, that was the easy part. Now finish it, they said. This was going to be a much longer task. We would have to code a lot more and have a lot more discussion. The long tail of the build was like, right, you have this internal dependency, and now how do we finish it? Our awesome designer had come up with a sketch file that had a lot of the components, and that was really awesome to use. It documented cells, views, buttons, type, colors, stock imagery, how and when to use them, even some names, and our job was to bring that to Swift. And we had these big discussions, and I want to go through them kind of one by one on a bunch of topics. As a committee, as a framework, we wanted to only expose API that would let developers create something nice looking without having to worry about design. If they passed in a few strings or an image, they were somewhat guaranteed to get something that design would approve of. The padding would be right, the colors, the fonts, the sizes, the weights, etc. If we could abstract away design thinking from developers, they'd be much, much faster at implementing screens. So the goal of the style guide was not to let developers create something ugly. Shout out to my girlfriend for helping me with my slides. For the API, we wanted to be consistent between components. So you pick up a component, you sort of intuitively know how to use it. But there's a bunch of ways to instantiate UIViews inside of iOS. So which one we were to use? There was a bunch of options. We went with something we called setup. So the initialization of the view, the cell, was assumed, and we would set up all the properties at once in one method call with setup, pass, and config. We use Swift optionals to imply visual optionality, such as like optional subtitles. And if you could pass it, it would be supported. We avoided very carefully like runtime assertions as to like just let the compile process tell you if you're going to make something ugly, which was kind of cool. In terms of component boundaries, like how much a component did, there was something we were trying to avoid. A legacy attempt at this sort of process resulted in a component called the flexi cell, which sends shudders down my head. You could pass anything you basically wanted to it, and it would come out ugly every time. And the code underneath that just handled unknown amount of arguments was also very ugly. So we were aiming for the opposite. We kept components simple, easy to maintain, and any significant variations got quickly broken off into a new component with its own code. Now, best practices. We came up with best practices as we were building this. And best practices are just a nice way of saying if you do this, the system will work. These are things that we thought of as a committee as we were designing stuff. Big ones being like, don't move it to the style guide unless it's going to be shared. If the designer comes with a new component, ask, why is this different to that other component? Use optionals, ask for help, and that sort of stuff. So lesson number 4. If you're designing something and thinking about something that's going to be used for other people, you're going to come up with best practices as you're thinking it through. So document those for others. It's really key to a successful project, I find. Naming, arguably one of the biggest challenges we had. And you know, it's hard in API design and it's hard in life. Is it Tom or is it Tim? We went through a few iterations of naming. We started calling the components by what we use them for, such as account summary view, and then we used it somewhere where it wasn't in an account summary view. So we started calling it what they had in them, icon, title, subtitle view, and then we got to icon, title, subtitle, status, arrow, indicator view, and we're like, oh, maybe not. So we went even more high level, and that ended up to be the for data view, and that we were happy with that. Prefix, yes or no, we went with the SG prefix for style guide. It's what we called our dependency. And for things like cells, we just ended cell, and things like views, we just ended it with view. But this was pretty arbitrary. There's no one right way to name things, build things. So we just went with what made the most sense at the time. Account summary view made the most sense at the time until we had new data. We debated a fair amount, and then we committed. And we didn't look back at those old debates. That debate and commit mentality gave us such good pace in these meetings. Now, fights are common in life and in work. It leaves people feeling pissed off, disengaged, resentful, want you to resign, that sort of stuff. But I think it's reasonably simple to solve arguments, especially in a corporate environment. And it basically comes down to this. Someone knows something that others don't. That's it. If you think something sounds dumb, just ask for the justification, hear them out, and then give your reasons. Usually, reasonable people, usually, end up on the same page. Usually. It's easy to get angry or frustrated, but it's just really a matter of time and productive conversation. The sooner you get to figure out what the other person's not saying, the quicker you'll end up on the same page. And everything went great after that. So thanks for coming to my talk. Oh no. I appreciate the clap though, that was great. We had some problems. Here's the problems in brief, but I'll only go through them one by one because they're really worth talking about. This is the really interesting stuff I find in this talk. So, one time we had a meeting. We don't really tell people we had our subcommittee meetings, but one of the old developers kind of just walked in and just sat down. He's like, I just want to see how the sausage is made. We're like, are you gate crashing our meeting? But, after the initial frustrations passed, we kind of thought about it as a committee, and like, what was our impression we were giving off by having these committee meetings? Were we having too much fun? Were we just taking an hour off work? Were we being cowboys and just running wild on the code base? Were we somehow being malicious? So the big lesson for us as a committee was employ empathy to see how our work might be perceived. We were being a bit secretive, we were being a bit quiet, so we just realised we weren't communicating enough back to the chapter as to what was going on in our meetings, what we were coming up with, what our thinking was. So we started doing some what we believe to be sensible things. Weekly updates back to the chapter, pairing with people on tasks as they started working with the library, writing down what we were up to and how to contribute. And then we did some stuff that didn't solve it. We opened up the meeting for everyone to attend. And that debate and commit stuff I described earlier, that was gone. People dragged up old debates. We had to spend time re-explaining stuff, re-explaining the foundations of our thinking, and our flow just dead. So we quickly undid that, and we went back to a small group. Designed by a committee of 12, just never works. With that said, we had the first version of the library out, and that was really cool. But this next mindset shift was a big one. The teams at Acme are tasked with making features and features for the app. But by the very nature of programming, as we know, we tend to write more generic solutions for the actual problem at hand. So it's always a balancing act, always, of building the thing for now and building the things so another team can build their thing faster later. But we got momentum as a team of teams when we looked to make common components as we built individual features. So just like how when you're working in a small team, you might make something more generic to help out a teammate, at a larger scale, that works the same for teams. Teams would look at other teams' backlogs and figure out if there's any commonality between goals and that sort of stuff. So it's really just the same thing, it's just a different scale. And of course, what we'd forgotten as well is our little secret project was starting to be not so secret. And it was starting to have an impact on our teams. And remember, our teams are made up of not just iOS developers, and all of a sudden there were some style guide stories on our Jira. Of course we use Jira, we're a corporate. And the rest of the team was confused. So for our business analyst, what I assumed would be a non-optional subtask as a way to think about this, turned out to be a bit of a bigger deal. Our BA had not really got agile, but rather they just learned a series of processes. So when there was this new task on the board, they had no instinctive way to problem solve and sort of figure out how to go about it. So that initially caused her some frustration, but we had a chat about it and designed some processes as to how to handle these, how to mark them, label them, and put them through the board. There's a lot of people like this, and it's something as a developer that I kind of forgot, that people aren't problem solvers, and that's very much a developer thing. We are used to, we thrive on unexpected inputs, and we love just dealing and figuring out the best way forward. Some other people just do process, and that's fine, but it's just not the way I thought people thought about their roles. On the product owner side, product owner at Acme would always question, do we have to do this thing? And if we have to do this thing, what's the fastest way to do it? They kind of loved tech debt. And as a developer, it was your job to kind of defend generic components, defend good code bases, adding the unit tests, building it properly. And some did this better than others. But by pointing out that this was kind of common practice already at Acme, they sort of quickly got on board. We have style guide components for our Android developers. We have one full of React components for our web app. So they were pleased to hear this actually happened, and I could demonstrate very easily the times we'd used components already to build things much faster. So that was really cool. Just a conversation to have. So we all know what devs do. We build code, we solve problems, but do we know what others do? And this was my first corporate, and I didn't really have testers before. I never really had business analysts, product owners. And so I had to take the time to kind of learn about their roles, what they think they do, their expectation for their roles and for themselves and others, how best to work with them and how best that they work. So it's worth, that's the lesson. Think about what mental models people might have for their own roles. Now, as a developer, you instinctively know what a piece of code does where, hopefully. You understand imports, targets, and all that sort of jazz. And you understand, hopefully, the impact of a piece of code on the code base, hopefully. But our testers didn't have that instinct. They weren't developers, they were sort of more manual testers. They like to be told where to test, how to test, and when to test. And that's fine. This style guide thing was new. So what we did is we built a style guide test app. It just had a list of the components and showed all their variations. It was super quick to build and run and very quick to use. And we put in variations that sort of made sense to testers and designers to think about. Things like text overflow, what happens when you have an 100-word string in that title label, screen sizes, rotation handling, image scaling, image cropping, with or without subtitles, optional values, that sort of stuff. But our phase 1 was just another smaller library. We'd just made it common for UI. So the lesson for us was, well, a new, smaller codependency isn't yet an external dependency. As some sort of ray of sunshine, all those meetings I had with leadership, begging for some real time to fix this code base for the next 10 years, actually came to something. It was amazing. We were given some time, weeks at a time, to form swarms, as we called them, to solve these problems. They would take developers away from their teams and would work on the code base explicitly. And so our first swarm was aimed at modularity. And that meant time for a dependency manager. So everyone get out your knives and we'll talk about which one's the best. So what to choose? CocoaPods, Carthage, Git, submodules, subtrees, Swift package manager. Long story short, we went with Carthage. Why? Well, we're all sort of getting used to this sort of stuff. So Carthage is very easy to get started, very easy to use, and it was very easy to take out if we changed our mind. And finally, CocoaPods wouldn't install over the corporate network. It triggered, the specs repo triggered a virus scan, and that means that any attempts to install it would time out. But we actually took real time to research these. We implemented all of the dependency managers. I did CocoaPods at home on my network. And we asked devs and testers to sort of figure out what made the most sense to them, what felt easy and good to use. And so that's how we got to Carthage. So lesson 10, take the time, do the research. This is when new hires started to pop up with what worked at their previous company. And so the lesson here is what worked at your last company might not work at the next. Don't forget, having a favorite or preferred piece of technology is not being a good engineer. Being a good engineer means solving unique problems with unique constraints, and you have to use a unique solution. So, solving that testing problem, the big mindset, semantic versioning. What's semantic versioning, you ask? Good question. Semantic versioning is a big old fancy number system that is x.y.z. X is the major version number. Breaking changes, they're non-compatible. Y is the minor version number, additions and deprecations. And Z is the patch version for under-the-hood changes and bug fixes. But to me, semantic versioning is more than just a fancy number system. It's about making a promise to the people using your dependency. If you're going from 1.2.1 to 1.2.2, I promise not to break anything in this version. If you're going up to minor version, I promise you'll see new stuff, but it won't break old stuff. And if you're going up a major version, well, something's going to break. I can promise you that. So, to actually make things a bit more complicated with semantic versioning, we had a slightly unique situation. Most code libraries semantic version on the API, like the method names, the arguments they take, the returns, the things they return, return types, side effects, that sort of thing. But since this was a visual component library, we thought it was logical to semantic versioning the visual contract. So if a button changed color, that was a major version change because it might not look good on a dark background or a light background or a different background. So button colors, typographies, image moving up and down some pixels left and right, that would need to be called out in the semantic version as well. Also the release notes. So using those, so as we got those new versions, we could test and watch for changes in both the visual contract and the coding contract. So semantic version turned out to be quite bizarre for some. Thinking about these promises really confused people, and our testers, well, how did they test semantic versioning? They're not terribly technical, remember? Well, developers had to test more, and that was something kind of new at this Acme company. So they had to sort of learn about semantic versioning and sort of ensure that promise was correct. Our testers had a hard time verifying this, so that's where we put in some coaching around that to sort of figure out if they could, we could see that they could tell if the semantic versioning was correct or not. But we had a lot of questions come up about semantic versioning. And the most interesting one was, harkening back to the start of the talk, is why do I not have to test both apps? So this is really, and I mean really, probably the biggest mindset shift for us when we started using managed dependencies. Pulling code versus pushing code. We used to push. You'd change it, it would automatically go into both apps. You'd be responsible for anything you'd possibly affect. That means both apps. It was a slow and frankly embarrassing way to code. As an example I gave to the team, Apple doesn't test our apps, for example, when they update UIKit or fucking rewrite the whole thing. They don't come to Acme and be like, hey, we've changed it, can we just test your stuff? No, they just push it. And so that was what they did. So now we pulled. A change would be made to this dependency, and if we needed that change, that updated code, we'd pull it in. The responsibility of that new code and its impact was on the person pulling it at that time, which could be much later. It would be no different to the code you added to add a feature to app A or app B. So for a new feature, if you just added some code, pulled a new style guide version, all that work was expected to be tested then and there, and that works much better. Now, this probably seems obvious to you. You're probably sitting there going, oh my God, yes, of course, I know push versus pull. And it was to me too, and I work like this all the time. I've done Ruby on Rails and Ruby gems, Node packages, CocoaPods, even Maven, Nougat, that sort of stuff. Throughout my career, I've lived and breathed packages, and doing it again, why was it taking everyone so long? Well, they just hadn't done it before. Acme had some really long-serving stuff, and they'd never seen programming paradigms like this. You remember, package dependency and management's really kind of somewhat new. And on the other end of the spectrum, we had some new graduates who hadn't really experienced this in a university environment either. So this frustrated me initially, but after a lot of biting my tongue and kind of personal reflection, I chose to teach and help rather than berate. And so I'd recommend you do the same. Now, a question I asked people as they were continuing to get their head around semantic versioning, push versus pull, dependencies, and all that sort of stuff was this. What if you couldn't get out of your chair and ask questions or give advice? And it was quite an interesting question to ask. And this is how I coached our chapter into solving it. Even though we had an internal dependency just for Acme use, I wanted people to think of it as an external dependency. What do you do when you can't get out of your chair? You're sick, working from home, left the company. You have to think hard about your communications. And that means having a great README with sections like how to build, run, contribute, and much more. Nailing that semantic versioning, being true to it, and following through on those promises. A changelog that tells you everything you need to know. And it's really easy to skim when someone's jumping multiple versions, just looking for a fix to a component. A great API. If you wouldn't use it, why would other people use it? Great docs, clear code that just answered questions that people had in their mind, removing all doubt, calling out gotchas or any sort of warnings. Just in general, build a great developer experience. And what I mean by developer experience is it's like user experience, but for developers. Now, I love this topic so much, I've written a lot more about it at that link. So why are we doing this? If you take 5 minutes to write some good docs, a good changelog, and nail that semantic version number, you'll save literal man hours of humans' time and conversation. It was awesome, and I got to see it work firsthand. And at a corporate, that glimpse of efficiency is so, so beautiful. And so we went on. Semantic versioning started to click with most people. We made multiple versions of the style guide per week. We introduced more dependencies. We went to an API library and then worked on a utils library, and we were on our way to TSA. So once again, I'll come back to this. Software engineering is multi-version, multi-person programming. I'm proud of the team I worked with. It was a hell of a growth year, but it was really, really worth it. And I'll leave you with this Māori proverb. He aha te mea nui o te ao. He tangata, he tangata, he tangata. What is the most important thing in the world? It is people, it is people, it is people. We introduced a library at a corporate. The code, that was the easy part. But the people, the mindsets, the conversations, and the lessons learned, that was the important part. Thank you very much.